Welcome to the Deep Dive, the show that takes a complex topic, loads up a stack of sources, and delivers the absolute core of knowledge and insight you need to be genuinely well-informed.
And today we're embarking on a deep dive into an individual whose singular creation underpins, well, perhaps the most transformative communication medium in human history, the World Wide Web.
Right.
And our mission today is sort of twofold. We need to go beyond just the inventor's narrative, the simple story. We want to thoroughly examine the precise technical components that Sir Tim Berners-Lee actually engineered.
And then, maybe even more importantly, we need to look at what came next. His decades-long and often really fraught fight to preserve the open, decentralized structure he originally envisioned for it.
Exactly.
Okay, so let's just jump right into that. We're talking about a scale of achievement that is, it's almost unique in the modern era. When you try to quantify the impact of the web, the sheer magnitude of the recognition he's received really hammers it home.
It's so true. The accolades aren't just, polite acknowledgments. They really place his work in the highest possible cultural and historical context. Look at Time magazine, for instance.
Mm-hmm.
He was named in their list of the 100 most important people of the 20th century. Think about that. That's a profoundly long timeline to have an impact on. It puts him alongside figures who fundamentally reshaped global politics, science, industry, everything.
And it goes beyond just commentary or lists like that. In 2016, there was this panel of 25 really eminent figures, historians, technologists, a whole range of people.
Right.
They ranked the invention of the World Wide Web as the #1 cultural moment that shaped the world. Number one, they were picking from a list of 80 transformative events, and the web just topped it.
And what was their reasoning?
They called it the fastest growing communications medium of all time and said it fundamentally changed the shape of modern life, commerce, and, well, society itself.
And then you have the technical community, which has its own highest honor, the Turing Award.
The Nobel Prize of Computing.
Yeah. He got the 2016 Turing Award, and the citation is incredibly precise. It really gets to the heart of his work. It was awarded for inventing the World Wide Web, the first web browser, and the fundamental protocols and algorithms allowing the web to scale.
That description, fundamental protocols and algorithms, that cuts straight to the architectural genius of it.
It does.
And that technical precision is exactly where we have to start. Because here's the crucial point, right? Concepts like hypertext, nonlinear linking of information, and the internet itself, the underlying TCP/DNS systems, they all technically existed before him.
Yeah, they were out there, but they were fragmented, siloed.
So what sets Berners-Lee apart is that he didn't invent the raw technology of networking. He invented the universally accessible system that unified them all. He took these existing separate technical ideas
and applied this layer of abstraction that made them globally applicable and scalable.
Like, you used this analogy before. He didn't build the highway. The internet was the highway.
Right. He invented the globally standardized traffic rules, the license plate system, the street signs, all the things that made that highway useful and intuitive for absolutely everyone, not just, a handful of computer scientists.
He created the organizational framework. He actually called it an act of generalizing, going to a higher level of abstraction, turning these scattered documentation systems into one larger imaginary documentation system.
It's a fantastic way to put it. And to really understand how he achieved that synthesis, we have to go back. We have to look at the environment that fostered that kind of thinking.
Okay, so let's start at the beginning, the foundations of this digital vision.
We begin with a family background that feels almost predestined for computer science. Tim Berners-Lee was born in London in 1955 to two, frankly, intellectual powerhouses, Conway Berners-Lee and Mary Lee Berners-Lee.
Mary Lee Woods.
Correct. And this isn't just a biographical footnote. It's profound. It establishes this lineage right at the very genesis of modern computing.
Because both his parents were mathematicians and computer scientists, and they worked together on a really foundational machine, the Ferranti Mark I.
The Ferranti Mark I, that's a huge landmark in computing history. It was the world's first commercially built electronic computer.
So his childhood wasn't just in a house that valued math and books.
No. He grew up in a house where his parents were actively pioneering the technology that would define the next century. They were grappling with the earliest challenges of hardware, software, instruction sets, the very building blocks.
And that environment seems to have fostered this really hands-on practical curiosity in him, We know as a kid he was a keen train spotter.
Which is an early sign of an interest in cataloging complex systems, right? Methodically collecting and categorizing data.
But he also learned about electronics, not just from theory, but by actually building and tinkering.
Yes, the model railway story is so telling. He used his train set to learn about switching, electrical circuits, control systems, all of it.
It's that approach, right? Understanding a complex system by taking its components apart and putting them back together again.
And that followed him right into his academic life. He went to the Queen's College, Oxford, and took a first in physics in 1976.
And while he was there, mastering theoretical physics, he was still doing this incredibly practical stuff. Which brings us to the famous story of him building his own computer.
And it wasn't a kit, not something he ordered. He literally built a functioning computer from discarded parts. The display was from an old television he bought at a repair shop.
That is the ultimate hacker mentality. Seeing the potential, utility in what other people just see as junk, and then being able to assemble those pieces into something new that works.
That ability to synthesize complexity would, of course, define his most important invention later on.
So after Oxford, he spends a few years really homing his skills, picking up the different pieces he would need. He worked at Plessey on communication protocols, then at DG Nash developing typesetting software.
And critically, these early jobs gave him essential, practical experience in computer networking, specifically through projects that involve something called real-time remote procedure calls.
So he was learning how systems talk to each other over wires, the final piece of the puzzle.
Exactly. And that path, rich with experience in physics, electronics, software, networking, all of it, led him, initially, to Geneva, to CERN.
His first stint there was as an independent contractor, just from June to December in 1980.
And the problem he found at CERN wasn't a lack of data. It was the opposite. It was a crisis of information fragmentation.
Okay, so what does that mean in practical terms?
Well, you had researchers all over the world generating massive amounts of documentation, experimental results, technical manuals, you name it. But all that information was scattered across different computers, different operating systems, different physical locations.
It sounds like a nightmare. A classic case of information overload, made worse by how fast-paced and collaborative particle physics research is.
Right. The researchers needed a single, reliable way to share, link, and update information quickly, no matter what machine the original document was on.
And Berners-Lee himself said the documentation situation was very difficult. He even called his drive to solve it an act of desperation.
And his proposed solution, which he came up with back in 1980, was based on the conceptual power of hypertext, this idea of a nonlinear information system where text could instantly link to other text.
And he didn't just propose the idea, he built a prototype to show it could work. He called it Inquire.
Inquire is the direct conceptual ancestor of the World Wide Web. It basically worked like a personal database that used associative links, letting him connect any document to another with a specific, defined relationship. It proved the concept worked.
But it's still local, right? Just on his own system.
It was local. So he returned to CERN as a fellow in 1984, and by 1989, the environment there had changed. It had matured. CERN had become the largest internet node in Europe.
So the network infrastructure was finally there.
It was in place, and that set the stage for the true global synthesis moment, the aha moment, as he called it.
Which was what, exactly?
It was realizing what the missing link was. He realized he needed to take his local hypertext concept, which he knew worked because of Inquire, and connect it to the existing global internet backbone, to the TCP and DNS systems.
And that is the leap that changes everything. Before that, people used the internet to, say, send a specific file or an email between two machines they already knew about.
But his vision was different. He realized the hypertext links didn't just have to connect files on one computer. They could connect resources across the entire established global network.
He called it generalizing, going to a higher level of abstraction. He wasn't inventing a new cable or a new kind of computer. He was inventing the unifying conceptual framework for how all those existing technologies could interact universally and seamlessly.
And that conceptual framework, delivered in a proposal his boss described as vague but exciting, is where the modern web was born.
Okay, so let's move from that conceptual breakthrough to the actual implementation. March 1989, he writes the formal proposal. His manager, Mike Sendall, calls it vague but exciting. Why vague?
I think the vagueness came from the sheer ambition of it all. I mean, he was proposing a universal system to solve a very specific internal problem at CERN. The scope linking all of human knowledge probably sounded less like a concrete project plan and more like, some utopian theory.
But the need it addressed was undeniable, hence the exciting.
Exactly. And he wasn't completely on his own in this phase. Robert Kallio, who had actually proposed his own hypertext project at CERN, joined him as a key partner.
Right, Kallio helped champion the project internally, which was crucial.
And the physical foundation for this digital revolution was a very specific machine, a NXT computer.
Steve Jobs' company, after he left Apple the first time.
That's the one. And that NXT machine, running the Next Step operating system, became the world's very first web server. It was the physical box sitting in his office hosting the initial version of the web.
So why was that NXT computer so important? Why not just a standard Unix machine?
That's a great technical detail that people often miss. The Next Step operating system was, for its time, revolutionary. It was highly object-oriented and had these advanced development tools.
Which allowed him to do what?
It let him rapidly prototype and develop all the essential software components. He needed an environment where he could iterate quickly on both the client, the browser, and the server, and Next Step gave him that flexibility.
And that rapid development led to the actual technical cornerstones, the fundamental protocols that are amazingly still running the internet you're using right now.
Exactly. He had to invent several interlocking pieces of software all at once. First, the client side. He built the browser, and he named it World Wide Web.
And critically, it was more than just a viewer.
So much more. The first browser was also an editor. It let users create, modify, and link content directly inside the application. That capability, the ability for anyone to both consume and contribute, was absolutely central to his original vision.
Then you have the server side, the engine room.
He wrote CERN HTTPD, the first web server. The D in HTTPD stands for daemon, which is just a background service that's always running, waiting for requests. It establishes that classic client-server architecture.
But the real genius, as you said, was the standardized architecture that connected them, the three crucial protocols, HTML, URL, and HTTP.
Their synergy is what made the web possible.
Okay, let's break those down. They're often just acronyms to people, but their individual roles are so specific and so important. Let's start with the presentation layer, HTML.
HTML, hypertext markup language. That defines the structure and the look of the document itself. It's what allows for that rich mix of text, images, and of course the embedded links, the hypertext.
Before HTML, document formatting was all proprietary, right, like specific word processing formats.
Exactly. HTML gave everyone a simple, open, platform-independent way to describe a document structure so it could be read anywhere.
Next, the addressing system, the URL.
The URL, or Uniform Resource Locator. This might be the most powerful unifying element of them all. Before the URL, if you wanted a file on a remote machine, you had to know the specific computer, the exact file path, and use a system like FTP. It was a mess.
The URL provided a universal, unique, and location-independent address for every single piece of information on the web.
And if you look at the structure of a URL, you can see his architectural thinking. You've got the scheme, like HTTP, which tells the client how to communicate.
Then the authority, the domain name, which tells it where to find the server.
And finally, the path, which tells the server which specific thing you're asking for. It's this beautifully simple three-part system for reliable global location.
And finally, the communication medium itself, HTTP.
Hypertext Transfer Protocol. This is the set of rules, the language that the client and the server use to talk to each other. It's a request-response cycle. The browser sends a GET request for URL, and the server responds by sending back the HTML.
So the moment those three pieces, HTML for structure, URL for addressing, and HTTP for communication, all snap together.
The system was live. The first successful communication between an HTTP client and a server over the internet happened in mid-November 1989. The web was technically alive.
And the public phase began pretty quickly after that. December 20th, 1990, the first website was published. Initially, it was just accessible from inside the CERN network.
And what was on that first site? It was completely self-referential. It explained what the World Wide Web was, how to use the browser, and most importantly, how to set up your own web server. It was the instruction manual for building the revolution.
And the official global invitation came a bit later, August 6, 1991. Berners-Lee posted an invitation for collaboration on the World Wide Web project to Usenet.
Usenet being the global bulletin board system of the time. That was the moment the web was really introduced to the wider global internet community.
It's just incredible how quickly it went from a proposal called vague to a global phenomenon, driven entirely by open source and shared standards.
It really is.
And speaking of technical standards, we have to mention the lighter side of his architecture, the notorious slashes.
Ah, yes, the slashes, the double slashes that follow the protocol, like in HTTP. In 2009, long after the web was everywhere, Berners-Lee admitted they were completely unnecessary.
He actually sort of apologized for it, didn't he? He told the Times newspaper he was sorry for causing decades of needless typing, saying, "There you go. It seemed like a good idea at the time."
It's a wonderful, humanizing anecdote. It reminds you that even the most world-changing architecture has these imperfect, late-night design choices baked into it.
But the fact that the slashes are one of the only things we can look back on as a mistake
Yeah.
just highlights how fundamentally sound, scalable, and adaptable those core decisions, HTTP, HTML, URL, really were.
Absolutely.
So we've established the technical foundation was brilliant, a perfect synthesis of existing ideas. But the reason the web scaled from a CERN documentation tool to a global medium, it wasn't technical at all, was it? It was a singular, extraordinary policy decision.
This is, I would argue, the most critical pivot point in the entire history of the web. If Berners-Lee or CERN had decided to patent the invention HTML, HTTP, all of it, and charge royalties,
The web would have just become another proprietary walled garden.
it would have. Think about the early 90s. The digital world was full of systems like CompuServe or AOL. They were robust, but they were completely proprietary. You had to pay them, use their software, and you could only talk to people inside their system.
Oh, by making the web available freely with no patent and no royalties due.
He enabled rapid, unimpeded adoption by absolutely everyone, competing software developers, academics, big corporations, regular users. This decision ensured maximum interoperability and guaranteed that no single entity could ever control the web's foundation. It was truly a gift.
It's an astonishing act of intellectual generosity. But giving away the blueprint meant he still had a responsibility to kind of guide its construction.
Exactly. And to manage the development of this now global open system, he founded the World Wide Web Consortium, the W3C, in 1994 at MIT.
And the W3C's purpose was critical. It wasn't there to control the web, right?
No, not at all. It was there to oversee its continued collaborative development by creating universally accepted standards and recommendations. And its core principle reflects his original commitment. All W3C standards must be based on royalty-free technology.
Which prevents any single company from locking down or privatizing core web functions.
Precisely. And this commitment to openness didn't stop there. Even as the commercial web was exploding, he kept his focus on academic work, on forward-thinking development, always looking for the web's next evolution.
Like in 2004, when he accepted a chair in computer science at the University of Southampton, he went there specifically to work on the semantic web.
Yes, this wasn't about the current architecture. This was about the web of the future.
The semantic web is a complex idea, but it's fundamentally brilliant. Can you break down what he was trying to achieve?
The idea was to move beyond the current web, which is largely human-readable. It's designed for us to look at and understand text and images. Semantic web's goal was to make data on the web machine readable by adding well-defined meaning or metadata to the information.
So instead of a web page just displaying the words Paris, France,
the data would explicitly define Paris as a city, France as a country, and establish the relationship between them. So computers could interpret relationships, context, meaning, not just display text.
which would allow machines and people to work together, turning the web into this massive global database that could answer sophisticated questions automatically.
Exactly. And this ongoing philosophical and academic work continues today. He's a professorial research fellow at Oxford, professor emeritus at MIT. He's always researching and advocating.
And this commitment to open standards quickly translated into public policy advocacy, especially around data. He started applying the same principles of openness to government information.
Right. He co-founded the Open Data Institute, ODI, in 2012 and worked on huge initiatives like data.gov.uk back in 2010.
And the philosophy there was groundbreaking for governments. Information, specifically government data, should be public by default, unless there's a very good reason for it not to be.
It completely reversed the assumption from keep it secret to keep it open. And he saw that as critical for promoting greater openness, accountability, and transparency.
And to broaden this mission beyond just technical standards and government projects, he and Rosemary Leith co-founded the World Wide Web Foundation, the WWF, in 2009.
Yeah, and the WWF really signaled his shift from being the primary inventor to being its moral steward. It set the stage for his most ambitious and I think necessary projects, defending the soul of the web from the forces of centralization that grew up around it.
Okay, so this brings us to the modern era. When you look at Berners-Lee's career in the 21st century, the focus shifts almost entirely to activism. He invented the system, watched it scale, and then had to grapple with the fact that the commercial structures built on top of it were threatening its original promise.
This is the era of defending the foundations. He immediately became one of the most prominent pioneer voices for net neutrality. This concept is incredibly important to him.
He argues that ISPs, internet service providers, should supply connectivity with no strings attached. So no controlling, no throttling, no monitoring customer browsing without their explicit consent.
And it goes deeper than just technical fairness for him. He frames this as a fundamental human right in the digital age. He calls net neutrality a kind of human network right and says that any snooping or interference from companies or governments compromise basic human network rights.
So what's the practical threat here? What does a lack of net neutrality actually lead to?
It leads to economic discrimination, which leads to fragmentation. If ISPs aren't neutral, they have a huge incentive to slow down competing services, say throttling Netflix unless Netflix pays them a fee, or creating fast lanes for their own affiliated services.
It breaks the level playing field.
Completely. Innovation suddenly depends on having corporate money to buy faster service, not just on having a good idea. That totally contradicts the permissionless nature of the web he designed.
And he didn't just write op-eds, he took direct action. In 2017, he joined Vint Cerf and other internet pioneers in an open letter urging the FCC in the U.S. to cancel a vote on net neutrality.
But the biggest threat he identified wasn't just interference in the pipes. It was the sheer, overwhelming centralization of user data by giant tech platforms.
Big tech?
Big tech. Companies like Facebook and Google built these massive, valuable empires by collecting and controlling data that originated from his open architecture.
Which led him to his most radical and ambitious project, the decentralization movement built around the Solid project.
Right. He's leading the Decentralized Information Group at MIT with the stated goal of fundamentally rebuilding the internet structure to achieve true data ownership and greater privacy.
So Solid is a huge architectural shift. Explain how it's supposed to work.
Okay, so right now, your personal data, your photos, your social connections, your purchase history, it all lives in these separate proprietary silos. Google servers, Facebook servers, Amazon servers. With Solid, your data lives in a personal online data store, which you control and you choose where to host.
This means the application layer is decoupled from the data layer.
Exactly. So if you use 3 different social media apps today, all 3 of them own and silo your data. With Solid, all 3 of those apps would access your single pod, and you, the user, grant specific granular permissions to each one.
So you could grant a health app access to your sleep data, but not your location history.
Precisely. And if you decide you don't like that health app anymore, you just revoke its access and your data stays safe in your pod. You're no longer locked into a platform because they own your data.
This is a radical idea that completely challenges the multi-trillion-dollar business model of big tech.
Yeah.
How does he plan to get this from an academic project into the real world?
That's where the open source startup Inrupt comes in, which he co-founded in 2018. Inrupt's whole goal is to build a commercial ecosystem around the Solid protocol. They're creating the tools and the support for developers and companies to actually transition to a Solid-based web.
So its success really hinges on developers adopting it and users demanding that kind of data sovereignty. That seems like an almost impossible task for an open source project going up against the inertia of these massive platforms.
It is the ultimate test of his vision. It's pitting the original promise of open architecture against the entrenched financial interests that have benefited from data centralization. He is betting that the growing societal demand for privacy and control will eventually win out.
And alongside these technical fixes, he also turned to global governance. In 2019, he and the WWF launched the Contract for the Web.
Yeah, the Contract for the Web is essentially a global campaign. It's designed to get governments, companies, and citizens to all commit to 9 specific principles to make sure the web is safe and beneficial for everyone. It was a clear call to action.
He warned that we have to prevent the web from being misused by those who want to exploit, divide, and undermine.
It's an attempt to create a shared moral framework, a recognition that technology alone can't fix these societal problems.
Now, we have to talk about something that complicates his image as this absolute, uncompromising defender of openness. The issue of digital rights management, DRM, and the encrypted media extensions, or EME, controversy.
This is a really thorny issue, and it highlights the difficult reality he faced as the director of the W3C, the body that sets web standards. The EME proposal was about standardizing how DRM, used by big media companies like Netflix and Hollywood, would work on the web.
And critics, like the Electronic Frontier Foundation, the EFF, argued that standardizing DRM fundamentally violated the W3C's open, royalty-free philosophy.
They did. And Berners-Lee tried to stay neutral at first, but in 2017 he felt he had to take a stand, and he chose to support the EME proposal. He argued it was a necessary compromise.
His reasoning was very pragmatic, right? He basically said that DRM was inevitable.
That was his logic. Media companies were simply not going to license their content without it.
So he chose the least worst option. If DRM was going to happen anyway, wasn't it better to standardize it within the W3C framework, forcing it to work across all browsers, rather than letting proprietary systems fragment the web into thousands of little content silos?
That was precisely his difficult calculation. As the director, he approved the finalized EME specification in July 2017, and this was met with fierce opposition. The EFF and the Free Software Foundation argued this decision compromised the web's founding principles in favor of commercial interests.
The EFF even raised a formal appeal, though it ultimately failed.
It did, and EME became a formal recommendation. His argument was that for the web to stay relevant as a platform for all content, including high-value commercial media, it had to meet the requirements of those creators. He saw a future where the web could become irrelevant if all the dominant media moved to proprietary apps.
So for him, standardization and universality trumped ideological purity in this one really difficult case.
It shows that even the web's inventor has to make these difficult political trade-offs to keep the whole platform unified and relevant.
It's a fascinating moral and technical tension. He's the architect who has spent the last 2 decades realizing that his perfect open blueprint needs constant, sometimes painful defense if the foundations are going to survive the massive skyscrapers built on top of them.
And the recognition he's received over his lifetime reflects that global impact. It bridges science, engineering, high culture, even royalty.
British monarchy certainly paid him respect. He was knighted by Queen Elizabeth II in 2004 for services to the global development of the Internet, which is, of course, where the Sir title comes from.
But an even rarer honor came in 2007, appointment to the Order of Merit. This is an incredibly high civilian honor bestowed personally by the sovereign. It's restricted to only 24 living members at any one time.
So it signals this profound, lasting national respect for his contribution.
It really does. And beyond the royal honors, he has pretty much every major academic distinction. Fellow of the Royal Society, National Academy of Engineering, honorary degrees from Harvard, Yale, you name it.
And his influence even transcended into high culture. In 2012, the artist Sir Peter Blake, famous for the Beatles' Great Pepper's album cover, featured him in a new version of the artwork. He was selected as one of the British cultural figures Blake most admired.
But maybe the most enduring cultural moment was his appearance at the 2012 Summer Olympics opening ceremony in London. That was a beautiful piece of technological homage.
He was seen working on a vintage Nexty computer, the actual type of machine that hosted the first web server.
It was a powerful reminder of the web's humble origins. And while he was typing, his iconic message was projected into the stadium seats using LED lights. It was this glowing text wave across the entire crowd.
That message, which he tweeted moments before, was so simple and so perfect. It was just, this is for everyone.
A phrase so central to his thinking that he later published a memoir in 2025 with that very same name, This is for Everyone.
And speaking of his legacy, even the actual source code he wrote has become this cultural artifact. In a very modern twist, in 2021, the original code for the web was auctioned by Sotheby's as a non-fungible token, an NFT.
And it sold for an incredible $5.4 million. The proceeds went to fund initiatives by him and his wife, Rosemary Leith. It's this amazing full circle. The original code for the free and open web was monetized using one of the newest decentralized technologies, with the profits immediately reinvested into promoting the web's ethical future.
When we look at his philosophy on the web's success, our sources point to one specific example that he cites as the pinnacle of what he wanted, and that example is Wikipedia.
He considers Wikipedia to be probably the best single example of what he wanted the web to be. And the reason is because it embodies this concept of intercreativity.
A group of people being creative together.
Yes, the idea of collective human knowledge, constantly updated, constantly self-correcting, and shared openly. That is the true realization of the nonlinear collaborative documentation system he first proposed at CERN all those years ago.
That idea of collective contribution and free exchange of knowledge really drives him. We should probably note, just for context, his personal journey. He was raised Anglican, later became a Unitarian Universalist, and now identifies as an atheist. His moral framework is really focused on shared human values and systems that promote collaboration.
And his current marriage to Rosemary Leith, an entrepreneur herself, extends that collaboration into venture capital, supporting AI companies that focus on responsible data management. His commitment is still firmly rooted in guiding the future of digital interaction based on the ethical frameworks he set up at the very start.
From the academic curiosity of building a computer out of junk to leading global movements for digital rights, his career has just been this continuous progression, from technical mastery to profound moral stewardship.
So what does this whole complex story of invention and activism really mean for you, the user, today?
Our deep dive into Sir Tim Berners-Lee reveals this unique dual role you rarely see in history. First, he was the singular engineer who, with just remarkable clarity, synthesized existing ideas, hypertext, TCP, DNS, into the foundational architecture of the web, HTML, HTTP, and the URL system.
But the invention was only the start of his commitment. His second and increasingly public role has been that of the tireless activist, the moral steward. Through the W3C, the World Wide Web Foundation, the Contract for the Web, and his fight for net neutrality, he has advocated for a web that remains open, transparent, and fundamentally controlled by the user.
Not by centralized corporations.
Exactly. The Solid Project and the startup Inrupt are the capstones of this activism. They represent this radical, final attempt to structurally re-engineer the web to ensure personal data ownership and decentralization, to restore the power balance back to the individual.
So the person who gave us the ultimate tool for universal access is now asking us to actively tear down the centralized structures, the Facebooks, the Googles, the data silos that have grown up around his original creation. He is demanding that we prioritize individual sovereignty over our data above the convenience of centralization.
And this raises the final provocative thought for you to consider. Berners-Lee's original gift of the open web succeeded because of a lack of existing commercial infrastructure and an abundance of human generosity. Now, facing the massive momentum, the network effects, and the staggering financial power of centralized big tech platforms that thrive on data control, can the philosophical fight for true data control, the goal of Solid, ever truly succeed in restoring the original decentralized promise of the World Wide Web? It's not just a technical challenge. It's a battle between architecture and corporate inertia. And you, the user, are ultimately the battleground.